let us have some examples of solving matrix equations. So we're asked to solve for x in the equation given these two matrices. So pause the video and try to see if we'll be able to solve these matrix equations. Alright, so let's start with the first one. We're given with number 1 as 2x plus a equals b. So 2x plus a equals b. We know that by not really transposing, but if we're going to have our, that should be x. There you go, plus a. If we're going to have a negative a matrix here, this will become a 0 matrix. And since I added a negative a here, I should also add a negative a here. And that is because if this becomes a 0 matrix, let's write that 2x plus 0. Since these are all 3 by 2, this is understood to be a 3 by 2 0 matrix. B plus negative a. We know that any matrix added to a 0 matrix will just result to that actual matrix. B plus negative a. So now, to make the matrix X alone, I need to remove this 2 by multiplying both sides by 1/2. 1/2. So therefore, the matrix X can be solved by getting 1/2 multiplied to b plus negative a. And let's do that. Let's just bring this down here. So therefore, I'm actually going to have x, I'll write it here, is equal to 1/2 multiplied by the matrices 0, 3, 2, 0, negative 4, negative 1. This is matrix B plus negative A. So that would be negative 1 multiplied by matrix A, which is negative 2, negative 1, 1, 0, 3, negative 4. So let's simplify this scalar first before we go to the other scalar. And let's just pull it up a bit. Therefore, we're going to have here as 1/2 multiplied by 0, 3, 2, 0, negative 4, negative 1 plus we have here 2, 1, negative 1, 0, negative 3, positive 4. So you can distribute the 1/2 first or add the two matrices first. Me, I'm going to add the two matrices first. So I need space again. There you go. We're going to have 1/2 multiplied by, if we're going to add all of these, then we're going to have 2, 4, 1, 0, negative 7, and 3. So multiplying 1/2 to the matrix will result to the matrix 1, 2, 1/2, 0, negative 7/2, and 3/2. So therefore, matrix X is equal to the 3 by 2 matrix 1, 2, 1/2, 0, negative 7/2, and 3/2. So there you go. So let's solve the other equation. Let's pull that up. The other equation is actually easier. The other equation is 2a plus 4b equals negative 2x. So x is already isolated and all we need to do is remove the scalar, so it will just be x. And to remove that scalar, we need to multiply both sides by this time negative 1/2. In turn, we're going to have x would be equal to negative 1/2 times 2, negative a, negative 1/2 times positive 4, minus 2b. And therefore, I'm going to have negative of, that's negative 2, negative 1, 1, 0, 3, 4, minus 2 multiplied to matrix B, which is 0, 3, 2, 0, negative 4, negative 1. Now, these are scalar multiplications. We know that. So, we're going to have first negative 1 multiplied to this matrix, which would lead us to have 2, 1, negative 1, 0, negative 3, negative 4. This becomes a plus negative 2. So, I'm going to have plus, then 0, negative 6, negative 4, 0, 8, and 2. There you go. And adding these two matrices, we're going to have 2, 5, negative 5, 0, 5, and oops, this should be negative 4. We forgot it there. So if this is negative 4, this should be positive 4. There you go. And therefore, this would be 6. So there you go. So therefore, for this equation, the value of x is equal to the matrix 2, 5, negative 5, 0, 5, 6. And those are examples of solving a matrix equation.